Hey guys, welcome back. Just TBH with you. Recorded this whole lesson and there was no audio, so this is round two. Hopefully it goes a little bit smoother than the first. Okay guys, today's lesson. I realize we just took a test on derivatives, but our next learning target is also about derivatives. It's just like a little bit deeper in derivatives and a little more the application side of things. So I really just have one problem to do with you guys today, and it's not a ton of fresh stuff. It's like some things that you've already done. It's some skills that you guys have already done before. So technically this lesson is about local maximums and local minimums and stationary points and all that, but I'm just going to call it mountains and valleys. So the book calls these things stationary points. Stationary points are basically the turnaround points. Let's draw a picture. Let's say I had some sort of graph that looks like this. I'm just making it up. Classic roller coaster, right? You guys have been talking a lot about tangents and slopes and things like that with derivatives. Do you guys see up here at the top of this mountain right here is a spot where you would have it switched, the graph switches from increasing to decreasing. That is called a local maximum. So like here, this mountain, this is called a local maximum. And it's a type of stationary point. Now, down here in the bottom of this valley, the graph switches from negative to positive. So like downhill to uphill, it makes a valley. So that means that this is a local minimum. Now, today's lesson, we're just going to do one problem together because honestly, like one problem doing this stuff by hand takes a long time. You could graph these things on your calculator and be like, oh yeah, it's about right there. But that's all of this stuff is kind of designed so you don't have to use that graph button on your calculator. That you can just use derivative concepts to figure out where these spots occur. So, let's see. The one example we're going to do today is find, excuse me, the stationary points of f of x is equal to 1/4 x to the 4th minus x cubed minus 5x squared plus 1. Excuse me. You guys, the first step with all this stuff is you're going to take the derivative, because the derivative, once again, is that slope machine that tells you the slopes of tangents on the curve. So remember that stationary points, if you were to draw in the tangent, like here and here, these have a slope of 0. So let's take our derivative, f prime of x, just use the power rule, x cubed, the old pop and drop, minus 3x squared, minus 10x, and then nothing on the end because the plus 1 just is 0. Now, you guys, stationary points are when the horizontal tangents have slopes of 0. So you can figure out where these are by just setting the derivative equal to 0 and trying to figure out what x is. Now, you might look at this guy right here and be like, oh my gosh, it's a cubic. I don't know how to solve cubics. It's usually a quadratic. You guys, it's not really a cubic. It's a quadratic in disguise. Do you see how all three terms have an x in them? That means you can factor out that x and get x squared minus 3x minus 10. Now, what's inside here should look nicely factorable. Two numbers that multiply to negative 10 but add to negative 3 are, of course, negative 5 and positive 2. So we get 0. And then this x just like hangs out on the outside. Just let it chill up front. X minus 5, x plus 2. Now, the same way that you would normally set your parentheses equal to 0, you're going to do that, but now you have an extra parentheses. This guy out front, you can think of like an x plus 0 if you want, but you got to set all three of those equal to 0 to get x is equal to 0, 5, and negative 2. You guys, this means that there are 3 stationary points on the graph. Now, your homework is going to be to like identify the maximums and minimums. So I don't know which of these are maximums and which of them are minimums. So to figure out what's what, we're going to do a zone test. But now our zone test has 3 points. Put them in order. So we'll do negative 2, 0, and 5. Bad 5, redo it. Now, you guys, we have to test 4 zones, actually. We have to test this zone to the left of negative 2. We have to test in between negative 2 and 0, in between 0 and 5, and anything to the right of 5. This is where it's a choose your own adventure. You can just choose any numbers that you want. I'm going to choose negative 3, negative 1, positive 1, and 6. So we need to plug those numbers into the slope machine, into the derivative. This guy up here is our slope machine, x cubed minus 3x squared minus 10x. So rather than write it with x's, I'm just going to write it with blanks. So f prime of blank is equal to blank cubed minus 3 times blank squared minus 10 times blank. So in those spots, here, here, and here, you're going to put in these numbers. Negative 3, negative 1. Ooh, that's not a good highlighter. Negative 3, negative 1, 1, and 6 need to go into those spots. Now I'm going to skip some of the algebra because, once again, the second time around, I've done this problem in the last 15 minutes. So if you plug in f prime of negative 3, you should get out a negative number. I think it's like negative 24 or something. Make sure that you're using parentheses around your negatives when you jam it into your TI. Otherwise, you're going to get the wrong answer. But it is indeed negative. Then if you put f prime of negative 1 into the slope machine, I believe you get out a positive. And then if you do f prime of 1 is the next zone we need to test, I believe you get out a negative. And then f prime of 6, I think, is a positive as well. Now, some people always come at me and they're like, Jolly, can't you just realize that the first one is negative, so then they're going to alternate after that? Yes, that's true most of the time, but there are problems where that's not true. So I want you guys to test every zone every single time because there are ones that you'll get caught with that method. So, you guys, let's use red, and we'll beef it up a little bit, maybe even here. You guys, the fact that f prime of negative 3 is negative, that means that the graph in that zone is going downhill. So it's a big down arrow. Then we tested negative 1 and got a positive, so that means the graph is going uphill in that zone. Then when you put 1 into the slope machine, aka the derivative, you get downhill, and then it goes uphill again. So this is the whole purpose of the zone test. It tells you what the graph is doing in terms of slope in those areas. So if I was to try to kind of sketch what this graph might look like, I bet it looks something like this. And on, with the number line, that this here is negative 2. When you get that bottom out, then at 0, you get a mountain. And then at 5, you get a valley. So what that means is that 0 is a local maximum because it's a mountain up here at the top. -2 and 5 are local minimums because they're valleys. You know that they're mountains and valleys because of how they switched. At -2, it switched from downhill to uphill, which is a valley, and then any switch from uphill to downhill is a mountain, and any downhill to uphill is another valley. So your final answer, like what you would report out to me, down the road, I think we're going to find the actual coordinates of these things. So like right now, I know that this point is 0, something. You could actually figure out what the y-coordinate is by plugging it back into the OG equation. Like this guy right here, you could plug a 0 in and figure out what the y-coordinate is. But I think that's coming down the road. So we're just going to leave it as just the x values for now. So my final answers would be, that we have local maximum at x equals 0, and then local minimums, we have 2, at x equals -2 and x equals 5. So if you guys can get to that point where you're not graphing it, you're using derivatives and zone testing to figure out what kinds of stationary points there are, I think we're fine for now. So I'm only going to throw one homework problem at you guys tonight, but it's got 4 subparts. But as you can see, these problems take a fair bit of work. So we're just going to do the one. Later on down the road, we'll talk more about how to find the actual coordinates of stationary points, and eventually we're going to get into some word problems that use some derivatives and calculus. All right, guys, HMU, if you have any questions, hit me up via email. Hope everybody's doing well. You're safe, happy, healthy. Drink a glass of water, wash your hands.